Hi guys, in this video we are going to be talking about the OLS derivations in case of multiple linear regression model. Now as I've told before, and I think I've mentioned this multiple times, that's ironical, the simple linear regression model has an equation where you have beta naught plus beta 1 x1 plus ui. So you have only one explanatory variable. In a multiple linear regression model, you can have multiple xi's, right? So you can have multiple explanatory variables. Now in the previous example on ANOVA, you actually saw an example of an equation where I had put in two explanatory variables. Now in the case of MLRM, you can obviously again use ordinary least squares estimation to kind of get to your estimators for the parameters, which are beta in this case. So if I have yi is equal to beta naught plus beta 1 x1i plus beta 2 x2i. In fact, let me just make our lives a little easier. So let's try to be a little more intuitive this time. So beta 1, beta 2 x2i plus beta 3 x3i plus ui. So this is your PRF, and you have your residuals sitting right here, your errors basically, right? If I were to write the counter, the sample analog for this, it would be b1 plus b2 x2i plus b3 x3i plus ei, right? Okay, so now when you are doing OLS, recall that when we started ordinary least squares, I told you that it's called what it is called because you minimize the sum of squared errors, right? So the idea here is minimizing the error, right? And when you minimize the error, because the sum of the error is actually equal to 0, as we have shown, and that's the first OLS assumption. So by the way, all the CLRM assumptions hold for SLRM, for MLRM as well. So we're working with the same sort of set of assumptions. I'm not going to go over them all over again because I think I've covered them in a fair amount of detail the first time that we've covered them. And it's, wherever I translate the CLRM assumption to the MLRM, I'm going to point it out. And it should be fairly easy to follow. In case it is not, my suggestion is to go back to the OLS CLRM videos and assumptions, because you cannot ignore the assumptions and move forward. The same principle that held true earlier, same holds true now. Econometrics as a subject is very, very, very connected, so it's important that you don't miss a thread here or there, and because otherwise everything will unravel in front of you. So we are talking about the OLS estimation in case of a multiple linear regression model, and we're minimizing the error because the sum of errors is 0. Therefore you minimize the sum of squared errors, right? Since you are minimizing the sum of squared errors is where you're deriving the OLS name itself, right? Okay, so like I said, your PRF is given by yi is equal to beta naught plus beta 1 x1i plus beta 2 x2i plus beta 3 x3i plus, let's say, ui, right? And here your beta naught is actually your intercept. So again, let me just correct that for a second. Sorry, please bear with me. I have a tendency to call it beta naught and beta 1, but it's important that for the purposes of this particular video we don't do that, because we want to derive things and we want to call them things that we don't lose track of. So okay, right? So this is the equation that we deal with. Okay, all right. Now beta 1 here is your intercept, right? Which is basically the average value of y in case x is 0. Beta 2 and beta 3 are called your partial slope coefficients or your partial regression coefficients, right? And beta 2 is nothing but del y by del x2. Beta 3 is nothing but del y by del x3. Now they're called partials because obviously you can see that you're taking a partial derivative. This is because when you interpret beta 3, you keep x2 constant. Here it is very, very important to not, undermine the strength of what you are saying. So when I say that beta 2 equals del expected value of y by del x2, what I'm saying in fact is that the beta 2 is equal to the change in the expected value of y given a unit change in the x2 ceteris paribus, right? So ceteris paribus, which is basically translating to all else constant. Okay, this is the same kind of condition that you must have studied when you were studying partial derivatives for the first time, but the idea here is that beta 2, if I were to interpret it, and this is something that you're asked multiple times in MLRM, how to interpret beta 2 or beta 3 for that matter, interpreting the slope and the intercept coefficients. Intercept is nothing but the average value of y when the x's are 0, right, like I just explained. And the slope is interpreted by saying, so beta 2 is the change in the average value of y due to a change, or a rather unit change, in x2, x3 held constant. Okay, every single part of this sentence must make it to your answer, otherwise you cannot expect full points. It is important that you talk about the change in the average value of y. That is, that's just the way you define this. It's expected yi or yi. If you say expected yi, then this goes away. So basically you only have beta 1 plus beta 2 x2 y plus beta 3 x3 I, right? That's the only difference. Okay. Why does this go away? Because according to your first assumption, the unconditional expectation of uy is in fact 0, right? Okay. So beta 2 is the change in the average value of y due to a unit change in x2, x3 held fixed. Had there been x3 and x4 in the equation, you would say x3 and x4 held constant, right? So ceteris paribus means all else constant, the only thing that changes is x2 in this case, and x3 and so on, right? Okay. All right. So now, I want to kind of attempt to derive the OLS estimators. Now this is going to be a long process. Okay, so my suggestion is to kind of in fact I think I'm going to stop this particular video right here. In the next video I'm in fact going to derive your OLS estimators. Thank you.